How are you guys today? I will keep it nice and short so we can have some lunch. Yeah, this is the sponsor talk, and I'm going to talk about the Hyperconverged database management systems because we believe that PostgreSQL, that's what it is, PostgreSQL, that's what is becoming PostgreSQL. And so yesterday as well, we briefly talked about the inception of PostgreSQL. So Michael Stonebreaker has been the leader of the original Postgres project, and the idea of having basically a ground-up rethink about our database should work, our database management system should work, and a multi-purpose database that it could fit a wide range of use cases. Actually, so the professor Stonebreaker at the beginning was like, "Oh, let's create, a database that can fit, all use case." He eventually changed idea and said, "This is not working out," and he went actually to create like a vertical, so a more specific use case database. And so the question was, well, can, Postgres, after all, is an elephant. Can an elephant achieve all of that? There are 343 databases at least out there. If you go to the DB engines ranking, you find as many listed in there. And so the question is, why so many? Do we really need, 300 and more databases? Of course, there's going to be always like a specific task in which there's going to be the tool that is going to be able to do that specific task better and faster. But having, does a company can allow in its architecture to have like a specific database for each activities, for each task? Or is it perhaps better to have, a database that can do a variety of tasks, then it can be suitable for a wide range of use cases, and perhaps not be the fastest of all, but be, secure, reliable, and do it, in a decent way, let's say. Having, that many specific database, again, in your architecture, how the whole architecture will run. Will that run smoothly? And, well, we don't believe so. Pretty much this, so this is this guy. It's a British science fiction writer, which basically he writes 3 laws. The 3 laws of forecasting. This one is the first one, and we used its first law pretty much. It give away what we reckon is the conclusion of the fact whether we should the Postgres, the elephant, can eventually succeed. And, when a distinguished but elderly scientist states that something is possible, is almost certainly right. When he states that something is impossible, is probably wrong. So you can see by stating that where I'm going to. Public recognition of PostgreSQL. We already mentioned briefly yesterday. So DB Engine Database of the Year 2017-2018 has been adopted in the cloud by about everyone. Again, other databases are really following what PostgreSQL is doing. And there's many forks. We talked about that as well yesterday. There's many forks, but the open source is very strong. And actually, all the companies that then or most of the company then build up some fork on PostgreSQL are actually the companies that then contribute back to the community. And so we believe that the elephant can succeed. Many ideas, many use cases. Again, so PostgreSQL it's born as a relational database, but it's also, a post-relational database, thanks to, many the fact that you can run extension on PostgreSQL. It allows, for geographical information. So you can have PostGIS running on with PostgreSQL. There is already, you can use as a full text search database, as already inbuilt a pretty strong and capable full text search engine. There's also on document-oriented. You can use XML and JSON with Postgres. You can use it as a graph or time series database, and it has business intelligence capabilities. I'm not gonna spend a lot of time. You all know what relational database is, and that PostgreSQL relational functionalities. Again, post relational. We discussed that PostgreSQL is extensible by design. You can create, you can customize data types, you can customize function, you can customize operation, but you also run extension on top. So you can use PostGIS, which provides special objects for PostgreSQL, and so it allows the storage and the query of information about mapping and location. You can use it as a full text search engine. There's many functionality already in PostgreSQL engine. It recognizes basically 33 token types. So when the parser supports 23 modes, basically the parsers are responsible for splitting raw document text into token, and it identifies basically 23 token types, different token types. We had, especially during the 90s, the emergence of NoSQL database, and basically, again, that functionality was of running JSON and JSONB, and having a document-oriented database type. It was brought into PostgreSQL. And there are studies as well that there have been done benchmarks that show better compression, that PostgreSQL has better compression than MongoDB. And if I'm not wrong, one of the study was made by one of the guys, and it's attending the conference as well.
Yeah, I think we share.
Yeah, we share. I don't know whether it's... full text search. There are many things that you can do. JSON, sorry. And then graph query database. As well, there's been proven that SparkQL queries can be written in SQL. there is actually an association called the Link Data Benchmark Council, which is a non-for-profit organization dedicated to establishing benchmark. Then it ran a benchmark in which basically shows again that PostgreSQL can be, specific database that were born for these purposes. And PostgreSQL time series. So again, you can use PostgreSQL to run time series. And business intelligence. We as well yesterday we mentioned that Postgres is a very highly analytical database. You can use it for business intelligence as well. So back to the point that we were making before. So there is a variety of additional modules that allow you to extend the, PostgreSQL. PostGIS is probably the most famous. Then you have TSS, then you got PGLogical and Postgres BDR, which are actually tools developed by Second Quadrant, and there are many, many others. So we talked about yesterday as well at the end of my presentation that as well it's extension is good because basically it allows to change extend the PostgreSQL functionality and basically it allows to Postgres to be adapted for new use cases without requiring upstream changes to the core of databases. So basically, the community can still work on its own pace to move at a very safe and stable pace, ensuring that all the solid foundation are kept. And whilst building extension can allow to move quicker because you don't have to follow, let's say, the same review process, the same review cycle of the community, and so you can be a little bit more agile. And these one are like all features pioneered with PostgreSQL. And so the point I was making before, it's can one, DBMS can be the best at everything? Probably not. But a project like PostgreSQL, which has such a huge number of contributors, that are, continuing innovating and bringing in new feature, and will allow over time to continue to cover new use cases. And so again, it is a slow process, but we will continue to expand all those functionality and expand the use case. And plus, as I mentioned, there's always the fact that you can provide those additional features quicker via extension. So when you look at PostgreSQL, you should actually look at PostgreSQL as an ecosystem, in which that's why we call it, hyperconverged system, in which you got. I wanted to actually. Yeah. You got PostgreSQL core, you got the PostgreSQL system extensions, and then you got the PostgreSQL customer server applications. So this is like multiple use cases bring all into one flexible system of interlocking components. And this is the reason why Postgres succeeds. Now, second quadrant, how do we come into this picture? Second quadrant is a heavy contributor to open source. We have many engineers that are contributors. And we also provide our own second quadrant Postgres version. We offer that to our customers if they want to. It's not a lock-in version. It just provides some extra features. Then again, they are not being brought into the core yet. And then we have developed with some other customers. So if you are on support with us, you can perhaps decide to use second quadrant Postgres. If not, you just keep using the community version. Many tools, like my colleague Arun basically provided you an overview of Barman, so for disaster recovery, and Rep Manager to manage high availability in the cluster, in a PostgreSQL cluster. And then we have PGLogica for one-way logical replication. We have BDR for bidirectional replication in a multi-master cluster. And so we are a developer of practical solution. We define ourselves as the enterprise PostgreSQL solution company. Basically, talking to our customer, our clients, we developed the project in a direction that we bring in the features and the functionality that companies need. We offer 24/7 production support, and within that we offer a 24-hour bug fix guarantee. This is more sort of a reactive service in which basically is the client then tell us then something wrong and then we act. If you like to have something more proactive, then we got the remote DBA service in which we monitor as well your service, and then we will basically notify that something went wrong and we fix it. We do PostgreSQL consulting. We offer training. Both of those services, we do it like remotely or on-site, depending on the client's requirements. And then, yes, we have basically a full product stack to enhance performance, high availability, security for your PostgreSQL apps.